Okay, so in this lesson, we will verify trig identities. You saw a little bit of this in chapter 4, but chapter 5 we will definitely go over some more complicated examples, but the general idea remains the same. The goal is to get the left-hand side equal to the right-hand side, and you can pick whichever side you want to work on. Typically, the more complicated side is the side that I would recommend working on. Now, please take a look at your notes on the guidelines 1 through 7. Just read over it. Basically, the guidelines give you different strategies on how to verify trig identities. And honestly, the best way to get better at these, right, is none other than just practice a lot of different problems. Okay, so let's take a look at this first example. Again, you are only allowed to use one side. And again, there's more than one way of doing these problems, all right? So I'm just going to pick the most convenient way based on what I see. I would say the right-hand side is probably going to be a little bit easier because notice over here I have a sine squared x on the right-hand side. If I just convert that sine squared x into a cosine squared, then the right-hand side and the left-hand side I can manipulate a little bit easier, okay? So I'm going to work on the right-hand side just so that we're clear. And when you work on the right-hand side, you must stay with it during the whole time. You can't, move terms around, divide terms over to the other side of the equation. You can only work on the right-hand side. Okay, so sine squared x, as you may remember, right, is just simply 1 minus cosine squared x, right? That's your Pythagorean identity. And then from here, right, if I just pause here a little bit, and think about how I'm going to make this right-hand side look like the left-hand side, it looks like the algebraic tool I'm going to be using is just quite simply foiling. And so let's do that. So 1 times 2, you'll get 2. 1 times 3 cosine squared, you'll get 3 cosine squared x. Right? Multiply the inner term over here, you're going to get negative 2 cosine squared x. And then if you multiply the last term, it looks like you'll get negative 3 cosine to the 4th x, okay? So from here, right, when you FOIL, you can typically combine these middle terms, and that just simplifies to 1 cosine squared x, which, I'm not going to write the coefficient 1. Typically, we don't do that. And now you can see that the right-hand side equals the left-hand side. Typically, I just use quotation marks to indicate that I'm done. Okay, so the algebra skill there, right, is obviously you need to know your Pythagorean identities. In fact, all your trig identities are needed. And then, of course, just a little bit of foiling. All right, moving on to example 2. Some of you might recognize this off the bat, right? The left-hand side looks like there's a particular pattern. And that pattern is none other than your sum of 2 cubes. Okay, so for reference, right, here's the formula again. A cubed plus B cubed. A plus B, a squared minus AB plus B squared. Okay, so I highly recommend that you have that memorized. Sum and difference of 2 cubes if you haven't already. Okay, so I kind of already gave away my tip here. I'm going to work on the left-hand side because it looks like I can do some factoring. So sine cubed x plus cosine cubed x, if I use this formula, A being sine x, B being cosine x, it would be sine x plus cosine x, right? And then it's sine squared x minus sine x cosine x, right? And then square the last term, so it would be cosine squared x, right? So that's the sum of 2 cubes factored using sine cubed x plus cosine cubed x. And then right away after I factor my sum of 2 cubes, right, I could see that I have a common factor that's going to cancel out. And the other thing I want to look at over here, right, is I have a sine squared x plus cosine squared x, which is basically your Pythagorean identity. Okay, so you're pretty much done after that one line of work. All you're left with is 1 minus sine x cosine x, right? And of course that equals the right-hand side. To indicate that I'm done, I'm just going to use the quotation marks. Okay, so again, right, you can see the algebra skill needed here is simply knowing how to factor and then canceling common factors. Okay, so let's move on to example 3. Just off the bat, It looks like the right-hand side's a little bit more complicated. And then once I do a trig substitution, it looks like I could do some foiling or multiplying. Okay, so tan squared x is, I'm going to work on the right-hand side just so we're clear. The tan squared x, as you know, is 1 plus secant squared x, right? So I'm just thinking out loud. But if I plug in a 1 plus secant squared x, I still have a tangent to the fourth x over here. So that doesn't really quite help me if I try to substitute, right? I could try substituting 1 plus secant squared, 1 plus secant squared x. My apologies. 1 plus tan squared x is equal to secant squared x, right? So I could try saying, tangent squared x is equal to secant squared x minus 1, but then I still have this tangent to the fourth x, right? And so something that I mentioned before, right? These trig identities, you're not going to necessarily get right off the bat. Sometimes you might have to just do a lot of trial and error. In fact, that's pretty common in doing these trig identities, okay? So it can be frustrating, but, I would encourage you to just persevere, race, and then try again. Okay, so as I mentioned, right, we could use this identity, but that's not going to help us because we still have a tangent to the fourth x, right? So what I'm going to do instead is just simply factor a GCF. Okay, so I'm going to factor out tangent squared x from the parentheses, and I have left 1 plus tangent squared x. Okay, so after I do that factoring, right, note my trig identity of 1 plus tangent squared x is just secant squared x. So now I'm just going to do a substitution of secant squared x right there. Well, secant squared x times secant squared x, of course, is simply secant to the fourth x. Okay, so I'm done. I've shown that the right-hand side is equal to the left-hand side. All right, so let's do one more here before I move on to another video. Okay, so again, right, you want to pick the side that looks more complicated. I would say this particular example, both sides look equally complicated. And so as an extra practice problem, right, I'm probably going to just do the left-hand side here. Try working on the right-hand side and see if you get the same result. Okay, so that would be good practice. Okay, so another strategy in addition to factoring and trig substitution is just kind of use that other side to help guide your work. And what do I mean by that is, so I'm going to work on the left-hand side over here. I notice that this term here on the right is a 1, right? That's an observation. And so what you can do is look at your expression here on the right side and ask yourself, well, how do I turn this term right here into a 1? How? Well, if you think about it, right, if I just multiply by 1 over tan x tan y, that will make that whole expression into a 1, right? If I distribute 1 over tan x tan y, or divide by 1 over tan x tan y, right? So if whatever I do to the top, I have to do to the bottom, right? Because that will be essentially multiplied by 1. So let's do that. And then from here, right, make sure you write your equal signs. You can start distributing. This times this, the tan x's will cancel out, right? But you still have the tan x's will cancel out. You'll still have a 1 over tan y. Right, and then this times this, right, the tan y's will cancel out. You'll still have a 1 over tan x. And then so forth, right? Distribute over here. You have a 1 over tan x, tan y, right? And then this was our guiding kind of step right here, right? When I distribute this into this, I'm going to get tan x, tan y over tan x, tan y, which is essentially 1, okay? So from here, right, you can simplify just one more line of work. 1 over tan y is just cotangent y. And then tangent x, 1 over tan x is cotangent x. Over here, I'm going to get 1 over tan x times 1 over tan y. Well, that's just cotan x, cotan y. Cotan x, cotan y. And then, of course, I have my minus 1. Okay, so I'm done. So this particular problem the strategy used here is to kind of look at the other side and see what I can do to the side that I'm manipulating. And, this particular problem was a little bit tricky if you didn't know the strategy. So that's something you can do. What you cannot do, right, is cross multiply and then start saying, hey, they both cancel out, this 0 is equal to 0, I'm done. That's not how you want to work it, right? You want to pick one side, stick with it during the whole process.